So for the third of our exercises, we will analyze the sound frequency of a sound and also obtain its global amplitude. So for that, we will use a technique called fast Fourier transform, or FFT. So I will use a sound I found in Freesound called game background music loop short. So it's quite useful to have, for FFT analysis, to have a sound that covers the frequency range. So a music track, if you have a music track, or if you find a music track, that would be ideal, because it has different instruments, in different frequencies, low, middle, highs. So that could create more interesting frequency analysis, as we will see. I already have that file in my computer, so I'll just add it here to my files. I'll upload it, and I will rename it just for the sake of obtaining the file name. And here I will call this exercise 3 AmplitudeFFT. Okay. So I will do as we did in the previous exercise. I will create a my sound variable or object to load the sound into, and then I'll create a preloader just to load the sound here. So I will say my sound equals load sound, and then I will just drop the sound in there. Okay, I can make this window a little bit bigger. Okay. Great. So we're loading the sound, and then just to make sure we can play it, I will create here a mouse pressed function to play the sound whenever we press the mouse. So my sound play. Let's check if everything is working fine. Great. So we are loading the sound and playing it. Now let's do FFT analysis. So to do FFT analysis, we need to create an FFT object. I'm going to say my FFT, and I will in setup I will define what is this my FFT. So my FFT equals new p5.fft, and we have the FFT reference in the sound reference, and this is how we create the FFT. So we say that the FFT is a new FFT, and then we can retrieve the FFT spectrum range and store it with using the analyze method, and then we store it in a spectrum array. So we have the FFT object here. Now to draw it, we can create a spectrum array, for example, and say that this is my FFT analyze is a method that we use to analyze the spectrum. Okay. So if we create an array, and I assume that you've looked at this in previous classes or in previous courses. If not, we can discuss in class. If you use an array, it's very useful to combine it with a for loop. So the for loop allows you to sweep through the array and obtain the different values of the array. How many elements will we get in the array? Well, by default, we will get 1024. So we know that frequency range, audible frequency range goes from 20 to 20,000 hertz, and we get this frequency range divided into slices. In this case, by default, 1024 slices, which is actually bigger than our screen, which is 400, right? So we won't even be able to see the 1024, but we'll just draw in any case, and then later we will change this size, and I will show you how we can change this size. Right, so to draw, we need to draw rectangles, and to draw rectangles, we need a height and we need a width, and I want to draw it across the screen, but with the frequency being mapped to the strength or the amplitude of the frequency to be mapped to the y-axis, so to the height, and then to have 1024 rectangles stacked across the width of the window. Of course, that's more than the width of my window, but later we're going to change it. So I'm going to say that let W for width. So the width of each of these rectangles is the size of my window, or width, divided by the number of spectrum frequencies that we have. And that's given to us by spectrum length dot length. So that's that property is the length of this array. Okay. And then we can have a for loop that goes through the array. So in the for loop we need a variable which will be the index of the array, and we say let I equals 0 semicolon I lesser than the size of the array, which is spectrum dot length in this case, and then I plus plus close the parenthesis, open the curly bracket. So in here we're gonna draw those rectangles, but to draw those rectangles we needed to stack them in the x axis. So we can say we can create an x here that will map this I value, the I index, which will go from 0 to 1023, because there's 1024 of them by default. We're going to map this, so map I that goes from 0 to 1024, but let's keep this variable so we can change this length later. So it's spectrum length, and we're going to stack them across the window, so from the 0, the left of the window, to width of the window, right? So with this, we can draw the rectangles, and we can say that the rectangle, the x will be this variable x. We can start by drawing them on the top of the window, but we're going to see that's not ideal. So what about the y? So the y will be 0. What about the width? The width, we have it up there, it's w. What about the height? So for the height, we could actually create a new variable here, which will be h, which we will map the value of each of these items of the spectrum to the height of the window. But what is the range actually of this of this analysis, right? So let's get here. So the analyze retrieves amplitude values between 0 and 255. So it's not between 0 and 1 like usually in amplitude, but it's between 0 and 255. So each of these 1024 numbers will be in a range between 0 and 255. So we're gonna map the spectrum, each spectrum I, which go from 0 to 1023, and the value of this number will be between 0 and 255. I'm going to map it to screen values in the Y range, which is from 0 to height, right? So we need now to drop that value here in our rectangle. And that's it for now. Let's see what we can get with this. So we have the frequency range you saw in that image, the frequency range. So the first lines were the low frequencies, then the mids, and then the highs, right? Okay. Now, I would rather have the lines being drawn or the rectangles being drawn from the bottom to the top. So how would we do this? Instead of starting to write them in 0, we would start them to write them in the bottom of the screen. But if we start to draw them in the bottom of the screen and then we have positive values for the height, we won't see the rectangles because they're going to be drawn downwards in the screen. So we need to bring them up. For that, we need negative values. So I just put here, instead of h, I put minus h. So we have 1024 values, but we can't see the 1024 because our screen is actually smaller than that. Our window is 400. So how do we change the FFT values? So when we create an FFT, by default, so let me show you. So by default, we have 2 parameters that we can insert here in the my FFT. So that's basically the smoothing and the bins. Smoothing is how jumpy basically the FFT analysis is from one frame to the next frame. Does it smooth the ups and downs in the amplitude of that frequency range or not? By default, it does smooth. So on a range from 0 to 8, the default of the smoothing is 0.8. And then the bins by default are 1024. So we can have, the minimum is 16. So we can put here, for example, 16, but then we also need to add the smoothing. So I'm going to put the default smoothing, and then the number of bins, I'm going to put it to 16. So let's see how this looks now. And with a smoothing of 0, so no smoothing, you will see those bars will be much jumpier. So I like to go with a kind of middle of the range type of value, for example 0.5. And now we know we can have more rectangles or less rectangles. It's really up to you. We notice that there's very little of the really high frequency sounds going on in here. Very little of that, which is normal. It's perfectly normal to have more low and mid and not real top of the high sounds can be a little bit irritating over time, and it's normal not to have so much happening there. So what could we do more? First, I want to create a little bit more diversity in terms of color here. So for example, I could have a black background and then map also the spectrum values to color, for example. And we can change the color of the fill or the color of the stroke. I don't want to use stroke, I just want to use fill, for example. So fill colors, we can use grayscale or RGB values. And I'm going to map the spectrum values to red. So I'm going to say spectrum. The spectrum range is the same as the color range, so it's very easy. We don't need map. We can just put them, drop them in the color red. Right? Sorry. Here we go. So let's see how that would look like. So this is an option that we could simply map the color of the spectrum to that specific value or bar, right? Or we could distribute and how this way the color is changing, right? Each time the color is changing. So not just the size of the bar, but also its color is changing. So we're creating purple color. So if the spectrum is low, spectrum value is low, we get more blues. If the spectrum is high, we get more purple, more magenta-ish kind of color. Right? Also, I don't like the line, so if I would like to remove the line or the stroke, I would just say no stroke, and that would draw the rectangles without the stroke. Right? So if you want to learn more about graphics in P5, just go to the reference, and in color, shape, you can see more about the stroke color, or adding no stroke, or removing the fill and just drawing with a stroke, for example. So you have all these options. You also have alpha values or transparency values that you can add as a fourth color parameter to create transparencies in overlapping elements. Finally, I would like to talk about amplitude. So we can calculate also the overall amplitude of the sound that is playing, right? So to do that, I'm going to demonstrate how to do that. I would create another object called myAmplitude, and I'll draw a circle with the overall amplitude of the sound. So instead of having the value of all the frequencies, what if you wanted just the overall, create a shape with that overall value? So it's basically the same method as to create the FFT. You just need to create, you just need to say that this myAmplitude is a new P5.amplitude. Sorry, amplitude with a capital A. And in the sound, you have something called P5 amplitude, and this explains a little bit how you get the amplitude. So then you need a level to get the amplitude get level, right? And then you can map it. But what is the range of get level? So it's between 0 and 1. Right? So we could create now, for example, a circle that obtains that level. We can say let. So this I can actually comment and organize. This is the FFT part, and now this section with a comment I can say this is the amplitude section, right? And we can say let's call this level equals my amplitude get level. So before we're getting the spectrum, the frequency spectrum, now we're just getting the overall level that is playing. Okay. And then we could map this level to the circle. We could create, for example, diameter value here, and this could be, we could map level that goes from 0 to 1 to, for example, 0 to the width of our window, and then draw a circle, for example, in the middle of the screen, which is width divided by 2, comma, height divided by 2, and then diameter, close circle. And what color would we draw it with? Well, if we don't define any color, it will be with the last value we get from the spectrum, which from the high frequencies was blue, so it will be blue, and to draw it differently we need to set another color. But let's just look how it works now. So this is the overall amplitude, not just every single frequency, but the overall frequency. So a bit the average of everything that you see in terms of frequency. So we get the overall frequency, not the the overall amplitude, not of each frequency, but of the average of each of all the frequencies. So if you want to draw it with a different color, for example, I don't know, white, it could be white, we could say fill, or yellow. And no, this is, sorry, this is magenta. So what if we want something more yellowish, for example. And that concludes our exercise on FFT analysis and amplitude analysis. Just kind of a postscriptum or addendum. If you had multiple sounds playing, you would want to map what amplitude you want to retrieve. In this case, it doesn't make much sense because we only have one sound. But I will demonstrate nonetheless. I will demonstrate how we would do it. You would say my amplitude here on setup, set input, and you would define which sound you want to get the input from, and in this case would be my sound. But it would only make sense if you have multiple sounds, because in this case we only have one. You won't notice any difference. But if you'd have multiple sounds without any set input, it would just average the amplitude of all of them that were playing. But if you would want to have a specific sound being tracked, then you would use this. And that's it for this exercise. Thank you.